Sorry about that. See if we can't pick up where we left off. Where were we? Yes, we said that negative x squared minus 5 is x squared minus 5. And for those of us who are wondering, how did I get that negative x squared was x squared? Well, I said negative x squared. I remember that squaring a number is the same thing as taking that number and multiplying it by itself. And negative x times negative x, well, a negative times a negative is going to be a positive, and x times x is x squared. So that's how I knew that negative x squared was x squared. Oops. Okay. All right, so sorry the video cut out. Let's remind ourselves what we were doing. We were trying to prove that this was an even function. So we said, okay, is f of negative x equal to f of x? Well, we've known from the beginning of the problem what f of x was. So then really the question was, is f of negative x the same as the original function? And we did some work just now, and we ultimately found what f of negative x was equal to. It was equal to x squared minus 5. So now we can go to our formula. Is f of negative x equal to f of x? Are these the exact same thing? And yes, they are. Both of them are x squared minus 5. So f of x, the original function here in black, was the same as f of negative x here in red. Therefore, this is an even function. And even functions always have y-axis symmetry. Okay. Awesome. So that one wasn't too bad. But let's realize we could have gotten around it pretty quickly if we realized that x squared minus 5, this original function, is just the quadratic that's been moved down 5. And you can see pretty quickly that that has y-axis symmetry. Okay. Let's do another one. Okay. Let's look at problem 2. So the first thing I'm going to do is, I know it says g of x, but if you want to call it f of x, you can, but I'll just keep calling it g. So is, well, let's not confuse ourselves any more than we have to. Let's just call it f of x. Okay. So we want to prove if this is an even function. So we want to determine, is f of x, the original function, the same as f of negative x? Remember, that's what I get if I plug in a negative x in for x. So negative x cubed minus 1. So let's be careful here. Negative x cubed. Remember, that's negative x times negative x times negative x. Well, a negative times a negative times a negative is a negative, and x times x times x is x cubed. So it turns out negative x cubed is negative x cubed, just like it sounds. And let's not forget the minus 1. Okay, so this is f of negative x. And now we can go to our formula and say, are these equal? Is f of negative x the same as f of x? That is what I've boxed in red the same as the original function in black? And hopefully we all agree that they are not the same. They are not the same. So what does this mean? A lot of people want to jump and say, oh, well, it must be odd then, right? And the answer is not necessarily. The only thing we know is that it's not even. So at this stage, all we can say is that it is not even. Unfortunately, it's not the case that if it is even, then it's not odd, or if it's not even, then it is odd. You can have a third option. So let's be very careful. We know we have just proven that f of negative x was not the same as f of x, therefore it was not even. Remember, this means a function is even, and we had just showed that it was not even. Okay, so it's not even. Then how do you show if something is odd? Well, there's another definition. A function is odd if the following is true. If f of negative x is equal to negative f of x, then it is odd. So these are our two formulas here. We have even functions have that property. Even functions have this property. Odd functions have this property. Okay, so in our example 2, we've shown that it's not even, but how do we show if it's odd? Let's look. So to show if a function is odd, you must show that f of negative x, which remember is this thing, negative x cubed minus 1, which we've boxed, we must show that that is equal to negative f of x. If what's in red is equal to what's about to be in blue, then it would be an odd function. So how do you find negative f of x? Well, remember, this is f of x, so how do you find negative f of x? Well, to find negative f of x, you're just going to multiply f of x by negative 1. Or, in layman's terms, we're going to switch the sign of everything in f of x. So it's not positive x cubed minus 1 like it is normally. Negative f of x would be negative x cubed plus 1. Do we see how we changed the sign or made f of x negative by multiplying everything by negative 1? We changed the sign of everything to get negative f of x. Okay. So in blue here, negative f of x is this. Okay, so is it odd? Is f of negative x equal to negative f of x? That is what's in red, boxed in red, the same as what's boxed in blue? And unfortunately, that minus and that plus are not the same, so they're not equal, which means it's not odd. So we've shown that it's not even and it's not odd, which means it is neither even nor odd. Okay, last one. Part 3 here, h of x. Again, so that we're not confusing ourselves so much, let's just call it f of x. So the first thing you're always going to do in these problems is check if it's even, because it's easiest to check if it's even. So the first thing I'm going to do is find f of negative x and compare it to the original function f of x. So what's f of negative x? Well, remember, always that's just what you get if you replace x in the original equation with negative x. And this is negative x to the 5th. Okay? So we've got our two functions here, and the first thing we can now answer is this even? Is the original function the same as what I got when I plugged in a negative x? And it looks to me like they are very different. So unfortunately, at this stage, all we can claim is that it is not even. Not even because this failed. Okay, so then maybe it's odd. We don't know if it's odd, remember, we just know it's not even. Maybe it's odd though. So to find if something is odd, we refer to a different rule. We have to check, is f of negative x, what's in red here, equal to negative f of x? Remember how we found negative f of x? We just took normal f of x and made everything negative. Well, it's pretty easy to make everything negative because, well, there's only one thing. So I just changed that x to the fifth and made it negative. Okay, so now we can say, is f of negative x, the thing in red, equal to negative f of x, the thing in blue? And the answer is yes. They're both negative x to the fifth, so that satisfies the odd property, which means it has origin symmetry.